These notes are going to go over how to balance chemical equations in order to satisfy the law of conservation of mass. So now that you've learned about the different types of equations, we're going to learn how to balance them. So in a chemical reaction, just to sort of reiterate the notes that you see here, bonds within the reactants are broken, the atoms are going to be rearranged, and new bonds are going to form in order to form our new products. Now, the law of conservation of mass states that matter cannot be created or destroyed. It can only be changed. So again, I sort of said this in class. That means that atoms can't appear or disappear. All that can happen is that they're rearranged and combined. So what that means is the mass of all of the reactants is going to equal the mass of all of the products because, and this is a really important part for balancing, because the number and type of atoms on the reactant side must equal the number and type of atoms on the product side. And that is what we're going to do while we are balancing. So when we are balancing our chemical equations, I like to use these first set of rules here for all of them. This here is a trick. I'll show you how to use it, and you can use it or not use it. And then these are just some helpful tips. Again, you can use them or you cannot use them. It's up to you. But these are sort of just like math puzzles. So the first thing you have to know is that you can only use the coefficients in front of the formulas to balance your equations. You are not allowed to change the formula. So you can't change what the products are or what the reactants are. So they have to be the same compounds. You can't change those little subscript numbers. You also cannot add terms or any sort of atoms or formulas to the equation. So you can't add a reactant or a product that wasn't already there. I always like to start balancing with an element that occurs only one time on each side of the arrow. That is more like a tip. You'll see me using that one. And I do balance starting from left to right, but you'll eventually start going back and forth. These are sort of the basic rules of balancing. I'll get into these other tricks sort of later. So what I'm going to do is I'm going to use this example down here to explain how we'll balance a chemical equation. So the first thing that I would like to do is I like to make a little table for myself. So I've got sodium and I've got chlorine. And I've got one sodium on the left side, and I actually have, if I look at this, I have 2 atoms of chlorine. So I'm just counting up my type of atoms and how many of them I have. On the right side, I still have Na, and I still have Cl. I'm going to write that over here. And in this case, I have in here just one Na, and I have one Cl. So we can see that there's a problem because I have more chlorine atoms on the left side than I do on the right side, and it looks like a chlorine atom has just disappeared, and that can't happen. So what I'm going to do is I'm going to put a 2 coefficient out in front of NaCl. That's going to mean that I now have 2 chlorine atoms because I now have 2 NaCls, and it also means that I now have 2 Na. So now that chlorine is balanced, I have to look at sodium. Now sodium has now become unbalanced, so I'm going to come over to the left side, and I'm going to add a 2 coefficient in front of the Na, and that's going to give me 2 Na. And now I have a balanced chemical equation. So in order for this reaction to actually occur, you would need 2 atoms of sodium to react with 1 molecule of chlorine gas in order to produce 2 molecules of salt, or NaCl. If we don't have 2 Na, then I can't make this. If I don't have 1 Cl2, I can't make this. So this is how many of each of these things I need in order to make my product. And now you can kind of look at it like a recipe. This is the recipe for making these products. So what I'm going to do is I'm going to take a look at a harder problem, and I'm going to use this little additional trick with the polyatomic ions. So we didn't learn or memorize any polyatomic ions, which is fine, but this will make balancing some of our bigger chemical equations easier. So I have a list right here of really common polyatomic ions, and the idea is if you see a polyatomic occur, so something like NO3, on the left side of an equation and also on the right side of an equation, then instead of separating it into nitrogen and oxygens and counting them separately, I would leave them together and just count the whole polyatomic ion. So I'm going to show you how I use this trick in order to balance chemical equations. You don't have to use this trick if you don't like it. You can just count up each of the atoms separately and then make sure they're balanced on the left and right side. For additional tips, I also save for last any element that appears in more than two formulas. So if it occurs in multiple chemical formulas on one side, I'll wait to use it. So I'll show you an example of that. Sometimes I'll leave my uncombined elements for last. So things like O2, I might leave for last because it'll help me just finish off the balancing at the end. We don't use the coefficient 1 to represent 1. We just leave it blank. And it's assumed that it's a 1. And then always check your work. I find the tallying system to be a really helpful way to keep track of my work. So I'm going to do a harder problem down here in part 3, and I'm going to do B, so we can do B together. And I am going to, these should all be arrows, sorry about that. So I'm going to make a little tally list of all of the elements that I see. And I'm going to take notice, I see two polyatomic ions. I see NO3 and I see OH. And then I see NO3 again on the right side, but I don't see OH again. So I'm only going to use the trick for NO3. Now, what I'm going to do is I'm going to tally up, I'm going to write down all the elements I see and tally up how many I have. So I have hydrogen, I have NO3, I have magnesium, and I have oxygen that's not part of NO3. So I'm going to write that list. And then I have hydrogen again, so I'll just add that to my hydrogen tally. On the right side, I should have the same thing. So I have hydrogen, I have NO3, I have magnesium, and I have oxygen that is not part of NO3. So now I'm going to use this system to tally. And I have one hydrogen over here, and then this 2 distributes because it means I have 2 OHs. So that means that I have 2 hydrogen there. So 1 hydrogen on this left formula and 1 hydrogen on this formula. That gives me 3 total hydrogen on the left side right now. I have right here my NO3. I have just 1 of them. And I have 1 magnesium. And I have, again, this 2 distributes. It means I have 2 OHs. So I have 2 oxygen that are not part of NO3. All right, so that's my tally system. On the right side, I'll count them up. I have 2 hydrogen. I have a 2 out here, which means I have 2 NO3s. I have 1 magnesium, and I have 1 oxygen that's not part of NO3. So now I'm going to do is just pick the easiest thing to balance. Now, I can already tell, looking at hydrogen, I have 1 here and 1 here. That makes this hard to balance, so I'm going to save it for later. I'm going to instead look at NO3 because I have 1 here and I have 2 here, and that seems a little bit easier for me to balance. So I'm going to use the coefficient 2 on the left side because I can only change coefficients, and that's going to give me now 2 NO3. But it also changes my number of hydrogen. So I used to have 1 hydrogen over here, but now I have 2 because I have 2 HNO3s. And I still have 2 hydrogen over here, so that gives me a total of 4 hydrogen. So I have 4 hydrogen on the left side, and I have 2 hydrogen on the right side. Again, I'm going to leave hydrogen for last if I can. I see that oxygen is unbalanced, so I'm going to go ahead and try to balance oxygen. I have 2 oxygen on the left side, so in order to balance that on the right side, I'm going to add coefficient 2. That's going to bring me to 2 oxygen, but that also changes my number of hydrogen to 4. And now I'm going to check that tally system. I've got 4 hydrogen on the left, 4 hydrogen on the right. I've got 2 NO3 on the left, 2 NO3 on the right. I've got 1 Mg on the left, 1 Mg on the right. And then the last one, I've got 2 oxygen on the left, 2 oxygen on the right. So now my chemical equation is balanced. All the atoms that exist and appear on the left side now exist and appear on the right side. So what you're going to do is you're going to go through this worksheet and balance them. Some of them are easier to balance. Some of them are a little bit trickier. If they are already balanced, you're just going to write the word balanced next to them so that I know that you looked at it and that you counted and you did your tally system. And then once you're finished with this on Friday, you are going to be submitting it. You are going to be doing parts 1 with your partner, part 2, which is a translation. So you're going to go from formula and you're going to figure out the formula of these names and try to write out the chemical equation and then also balance it. So this one's going to be a little bit trickier. So you'll do parts 1, then you'll do part 2, and then you do part 3, and some of these get a little bit harder, so they'll challenge some of your balancing skills. If you're feeling really into this, there is an extra part 4. You do not have to do this. This is totally optional. For additional practice, there are polyatomics that have been included here, so it does level up the difficulty. This will not be a level of problem that I expect you to be able to do, but the rest of them should be manageable.